Radio. First thing we might need to remember for solving a problem like this, there we go, is that, let's get a mouse, there we go, is that when we square a number, so if we have 2 squared, that will take us to the number 4. And if we have minus 2 squared, that will, if we have minus 2 all squared, then that will also take us to 4. So positively squared values give us a number, but a negative squared value to an even power will also give us a positive value, and we'll need that in a minute. Something else. Oh no, we're ready to start with this one. Okay, we have 2 bits of information in the question, and we'll write equations for both of them. So we can see this is a geometric series. Let's see if it doesn't change my mouse size. No, lost it in this one. Oh, we'll just have to stick with this size. So with this one, it's geometric series. So a given term number, I usually use Tn, but you can use An if you want, is given by the first term, A, times the ratio r to the power of n minus 1. Or we can use the recursive formula, but we won't use that one here, because if you're given, say, the second term and the 20th term, it will take you a while to get to that distance. Okay, we're going to fill this in for everything that we know. So the second term is 48. So the second term is 48, which means that the second term, the value of the second term is equal to the first term times the ratio times r to the power of 2 minus 1. And this, the value of the second term is 48. And the equation on this side, we don't know the first term, so it's still a. We've got r, which is the thing that we're looking for, and 2 minus 1 is just to the power of 1. We do this again for the other bit of information in the question. The fourth term is 3. So again, T4 is equal to our first value times the ratio to the power of now 4 minus 1, which is the fourth term we've been told is 3, so we can write that in there. Our first value is something that we still don't know yet, so it's still a. Our ratio is the thing we're looking for, so it's still r, and 4 minus 1 is 3. Now we have 2 equations, the one over here on the left and one over here on the right. 2 equations, 2 things we don't know, a and r, so we actually have a set of simultaneous equations. It's different to the ones we know so far, because usually we've got an amount of x added to an amount of y. Here they're multiplied together, so instead of taking one away from the other one, we can in fact divide these by each other. When we do this, the one that you want to put on top is the one which is to the higher power. Okay, it will just work out easier that way. You can see this is what we've done down in this section. We've divided the higher power equation by the lower power equation. So what we're going to do, I'll write these down and then I might flip them around. So what we've got written down in this section here is this equation. So pick a different color to highlight it, for instance. I'm going to write this equation first. I won't chop it off. That one. So we've got 3 is equal to I have 3, and instead of writing the 3 on that side, I'm just going to write the 3 on this side. And our other equation over there, this other equation will be, where do we go about there? We'll have a times r to the power of 1 is just a to the r, is equal to 48. This will be my equation 1, we'll leave that off, equation 2. And then I'm going to divide equation 1 by equation 2. So we're going to have equation 1 divided by equation 2, and that's going to look like a times r to the power of 3, and 3 on this side, so I've just written this equation again, divided by a times r, and the value here is 48. When we've got, where we might write this out again, this is a times r times r times r. A times r to the power of 3 is just a times 3 r's. And that one. And then we've got a r on the bottom and 48 over here. And when we're dividing by the same size terms and they're all multiplied together, we can cancel out. Okay, so this will, our a's will cross out and they'll be replaced with 1s, and this r will cross out and they will also be replaced with 1s. So now I've got 1 times r times r, which will be r squared. And on the bottom we've just got 1 times 1, and anything divided by 1 doesn't change, so it's just r squared on this side. And if we simplify this value of 3 on 48, and feel free to use your calculator if you want to, you'll find you'll get 1 over 16. So 1 over 16 equals r squared. If we square root something, if we apply a square root to both sides, so we're going to say that r squared is equal to the square root of 1 over 16. Right? If you undo something, if you apply a square root, you end up with the possibility of the answer being positive or negative. It doesn't go there yet. We end up with r here equals positive or negative square root of 1/16. Okay, and this is back to what I said at the beginning. If we take the square root of 4, a possible answer is positive 2 up here. So if we then go backwards and apply a square root, we could have gotten originally plus 2 or originally minus 2. We don't know how we got to this 4. So this plus and minus down here, okay, is due to the fact that we don't know if this r is actually positive the square root of 1/16 or a negative square root of 1/16. All we had is this leftover bit of information that when we square it, it equals 1/16. Okay, so if we work out this, if we take the square root of 1 over 16, feel free to use your calculator or square at the top and square at the bottom, we will get r equals plus or minus, we don't know which yet, 1/4. I'll put that in brackets. We need to write this both down, and then later on, if you know which one of these, you can cancel one of them out. So we've shown that one possible value, so I might write this down, r equals positive 1/4 or negative 1/4. Yeah, we don't know which one it is yet, but it could. And therefore we've shown that it could equal minus 1/4. And we've also stated the other value. So we've written that down there. And a sentence here would be, if r equals minus 1/4, then the other value is positive 1/4. Hopefully that makes sense. The rest of it you should be able to do yourself, because this is just applying the standard rules we've used out here. Term number of a geometric series is the initial value times r to the power of n minus 1. Right, yeah. Best of luck. Send me another email if you get stuck.